Hi, everybody. Welcome to our session today. We'll be covering an end-to-end machine learning lifecycle with Oracle's data science platform. My name is Elena Sunshine, and I am a Director of Product Management for Oracle. I'm here with my colleague who will introduce himself.
And I'm Jean-René Gauthier. I'm a product manager and a data scientist working in the Oracle Cloud Infrastructure Data Science Service.
Great. Let's get started. First off, we have this safe harbor statement, which applies to any future-looking statements that we may make in this presentation, including roadmap items. So I'd like to introduce to you the Oracle Cloud Infrastructure Data Science Service. This is a cloud service that supports the expert data scientist professional with support for Python and open source machine learning libraries. It is accelerated. We focus on how to accelerate the data scientists in their workflow, providing the tools that they want to work with, streamlining them, providing the best of the open source toolkit, and automating those workflows as well. It is collaborative. We not only think about improving the productivity of the single data scientists, but also making it so that teams of data scientists can work together in a collaborative manner and be able to share and reproduce each other's models in a structured way. And finally, it is enterprise grade. Again, it's a cloud native service that is fully managed on Oracle Cloud and integrated with the security and granular access control of Oracle Cloud that makes it meet the needs of the modern enterprise. So I'll be introducing some of the features and concepts that you'll see throughout JR's demo coming up. The first is projects. Projects are a collaborative workspace for teams of data scientists to organize their work. So all resources created within the data science service are created within projects, associated with projects. Projects are built around your data science question. What is the problem that you're solving or the use case that you're solving in that project? So you can document and organize all of the assets that are associated with solving that project in a single place. Within projects, we have another feature here that is meant to foster collaboration amongst the team, which is the model catalog. The model catalog is a centralized place where model artifacts and model metadata are cataloged and saved so that teams of data scientists can audit and reproduce each other's models. So first of all, we track all the model metadata. So where did this model actually come from? So colleagues can actually see where this model came from and track how to reproduce it. Then we save all of the model artifacts in a centralized location so that, again, teams of data scientists can view each other's work, can load each other's models, and can test, validate, and then deploy each other's models. The next feature that we have that's organized within projects is called notebook sessions. Notebook sessions are OCI, compute, networking, and storage, again, all fully managed, that comes together to give a Jupyter Lab interface for a data scientist professional to iteratively do their model development process. So this is where you will write and execute Python code and take advantage of machine learning libraries to actually execute your end-to-end machine learning lifecycle. We support a full suite of CPU shapes with AMD and Intel chips, and we also support GPU with the NVIDIA Pascal, Volta, and soon-to-be Ampere shapes as well. We provide persistent storage backed up on this notebook session, so you can come back to where you left off in the next day and get started right where you were. We also provide a Git integration for version control. Again, very helpful to have amongst a team of data scientists. And we provide an integration with the OCI Vault service, which allows for secure encrypted secret management. Within notebook sessions and actually any workload that's running on the OCI Data Science service, we provide a feature called Condo Environments. Condo Environments are a way for data scientists to package up all of the dependencies associated with their analysis or model so that their colleagues can come in, run the same analysis, and reproduce the same results in that consistent environment. It also enables the data scientists to train their model in environment and then deploy that same model in that same environment and make sure that it actually works in production. So we package a bunch of pre-built, curated Condo environments into the service that address a variety of use cases such as NLP, computer vision, time series, general machine learning, connecting to the Oracle database. There's a bunch of these that you can take advantage of. Another really cool feature of Condo environments is that you can actually install your own libraries and dependencies and versions that you require into Condo environments, and then save them down and share them with your colleagues. So again, if I create a model in my environment, I can deploy that same model in that same environment, and I can share it with my colleagues so that they can do the same. Again, ensuring reproducibility across an organization. And one of those libraries that we package within Condo environments is outside of the open source. It's actually a toolkit developed by Oracle called the Accelerated Data Science SDK. This is a toolkit that covers the end-to-end lifecycle of machine learning models, from data acquisition to data transformation, to data profiling, visualization, feature engineering, model training with AutoML, model evaluation, and explanation. You will see JR use this toolkit in his demo coming up. So with that, I will hand it over for part 1 of JR's demo.
Thank you. All right. So in this first demo, so I will be giving a demo in 2 parts. In the first demo, I will show you how to create a project and a notebook session on the OCI Data Science service. So the first thing I'm going to do here is walk you through the OCI console. So this is the starting page, if you want, of the console. And I'm going to go into the upper left menu, hamburger menu here, where I will see a list of all of the different services that are available on the Oracle Cloud Infrastructure. So if you scroll down to the data and AI category, you will see the data science service here at the bottom. So if you click on data science, you will see that the first page is the projects page. So let's click on the projects here. And so you see here a list of projects that have been created that are in different states. Let me only filter the active projects that are ongoing right now. So you see a list of projects. All of these projects are associated with a particular compartment that you see here on the left. So this is called the demo compartment. You can think of a compartment as a logical entity that allows you to basically create resources. These resources are contained inside of those compartments. And then you can control access to which group of users can access which compartment. So it's a great way to segregate resources, to control access, and to segregate resources for different teams that maybe are sharing the same OCI tendency, or different teams of data scientists, perhaps. So I will show you how to create a project. It's a very simple flow. So you select a compartment where you want the project to be. You give it a name. I'm going to call this the AI ML for Enterprise. And you give it a description. It's optional. You can also tag your project. You can add a tag key and a tag value here, and you create the project. It's very, very simple. The next step is, once you're in a project here, you can take a couple of actions. You can create a notebook session, or you can create and save a model. And pretty soon you'll be able to take a third action here, which is to deploy a model, and a third resource here called model deployment. This is upcoming. So the first thing I want to show you is how to create a notebook session. It's a pretty straightforward process. So let me just click on Create Notebook Session, and you'll be directed to a mobile window. And you have to provide some parameters. So again, here, like any other OCI resources, you attached a compartment to your session. You give it a name. So I can just call it, say, like test EDA. You're gonna run your notebook session on a compute instance. And we'll give you a variety of options on which you can use for notebook session. So we support the what we call the standard E shapes, which are AMD CPU chips VMs. There's different number of what we call OCPUs, and OCPU is a hyper-threaded CPU, so it corresponds to really 2 CPUs here. So you go from 2 to 8, and there's different amount of memory also on those. You can use a standard 2 shape. Standard 2s are Intel-based CPU shapes. And again, you can use a small shape, standard 2, which only has, I believe, 1 OCPU and 8 gigabytes of RAM, all the way to a 24 OCPU machine with 320 gigs of RAM. So this is for larger workloads. We also support 2 generations of GPUs, so the P100 and the NVIDIA V100 Tensor Core GPU, which on a single VM, you can have 1 GPU, 2 or 4 GPUs for very large distributed workloads on GPUs. So the great thing about Notebook Session is that you can start to work on a small VM shape. You can, what we call deactivate your Notebook Session. The deactivation process, what it does is that it releases the VM. So you free up the compute. So we stop the billing process when the compute shape is being freed. You can, what we call the reactivation process, which means that you can later on pick a larger shape or a different shape and then pick up where you left prior to the deactivation step. So how do we do this? Well, what we do is we attach a block storage drive to your Notebook Session. So we give you options between 50 gigabytes and 1 terabyte. So what we do here is that all the data, the notebook, the scripts that you create in your Notebook Session are saved and they're persistent in that block storage. So when you deactivate, we free the compute, but all of the data persists on disk. So when you want to reactivate your Notebook Session later, we just reattach the disk to perhaps a different VM. So then you can resume your work. And then the third component that you need to specify when you launch a Notebook Session is the networking. So you need to attach a VCN and a subnet to your Notebook Session. And so what this allows you to do is it allows you to configure your networking. So what data sources perhaps you want to access to. Perhaps you want to access data sources on premise. You want to maybe give your data scientists access to the public internet. So this is a very flexible option here that allows you to route egress traffic to a particular VCN and a subnet. So I'm going to complete this step here. I'm going to select the VM shape and the amount of block volume, and then I'm going to create a Notebook Session here. So this process will take a few minutes, and I will get back to you in my second part of the demo, and I will show you the actual notebook experience itself with the Jupyter Lab, ADS, and the Condo environment. So I will turn the mic back to you, Elena. Thank you.
Thanks, JR. So in the next part of JR's demo and throughout the rest of the presentation, I'll be walking you through the data science project lifecycle, which starts with data acquisition, data access, through model deployment and beyond. From a data access perspective, the OCI Data Science service makes it very flexible and easy to configure your networking and use built-in Python connectors to access your data anywhere. So we are data source agnostic. This means that data can, of course, be stored and managed within Oracle Cloud. It can also be stored in another cloud, for example, on Azure, Google Cloud, AWS, or anywhere else. It can also be stored and managed on premises, and we can connect through your data center to your data. And it can also be data format agnostic. So we accept structured, unstructured, semi-structured data, any type of data that you need to work with within your project, you can bring in. Next step, data transformation. So you may have some large scale data transformation that you need to accomplish before you can set about your model development process. We integrate with another service on OCI called Dataflow. Dataflow is a managed service for running Spark jobs in batch mode at scale with no clusters to provision or maintain. So again, all fully managed in a serverless style of operating. So our integration with Dataflow provides an interface from our accelerated data science toolkit to create and run Dataflow applications from your data science environment. We also provide a PySpark environment so that you can develop your code in your Notebook Session in a local environment and then offload it to Dataflow when you need to run it at scale. Next step is model training. You can, of course, use many different types of model training, any of your favorite open source frameworks, including open source AutoML frameworks, but we also offer Oracle's own AutoML engine. So Oracle has been developing within Oracle Labs throughout the last several years of R&D and our own AutoML engine. So this AutoML engine does automated algorithm selection, it does data and feature selection for you, and automated hyperparameter tuning. So you can essentially take a data set and spit out a really good candidate for a model for that data within a very short amount of time with very low effort. Once you have a model trained, whether you trained it with an open source framework or with the Accelerated Data Science Toolkit's AutoML, you can use our evaluation functions within ADS to help understand how well your model is actually performing. So what is the accuracy and performance of that model? We create these charts with just a single line of code. So we were automatically creating these visualizations for you in a smart way. Depending on the type of model that you've created, you'll get lift charts, gain charts, precision recall curves, ROC curves, a suite of metrics, and even confusion matrix if it applies to your model type. Now that you have validated the accuracy and performance of your model, you may like to actually use some explanation techniques to determine why the model is behaving as it is. So again, in collaboration of Oracle Labs, our team has developed our own framework called MLX, which is embedded within the Accelerated Data Science Toolkit, which will help you with model explanation and interpretation. It provides automated model agnostic explanations to help, of course, improve your understanding of the model's behavior and help you, of course, trust the results that you're getting. You can also use it to help address some regulatory needs if you work within a regulatory industry like finance, for example. And across an organization, it can help you to debug and increase the speed of ML adoption. These global explanations help explain an overall behavior of the model. We also provide local explanations to help explain specific model predictions. So what features of this model were driving this particular prediction to be what it is. You can identify perhaps any bias that may be associated with your model. So once you have generated your model, you have validated it, and decided that this is the model that you would like to deploy, there are multiple deployment options for you on Oracle Cloud. One of those deployment options is to deploy your model through Oracle Functions. Oracle Functions is a fully managed, highly scalable, on-demand functions as a service platform. So you can basically take your model, embed it within a Docker container, and deploy that Docker container on Oracle Functions in a managed way, and it will scale out for you. Then you can use this function as a backend to invoke machine learning functions from your custom applications. Another option for deployment is managed model deployments. So this is a feature that is coming very soon within the data science service, which basically enables you to deploy models directly from the model catalog that we discussed earlier, again, as managed endpoints. So all of the infrastructure that it is relying on, it will be managed by our service. So there's nothing for you to maintain, provision, upgrade, patch over time. That is all handled by the service. Because you can deploy these models straight from the model catalog, it is an extremely streamlined manner of deploying your model. You basically have one step once your model lives in the model catalog. And we provide access to the logs so that you can analyze your inputs and predictions for model drift analysis. And with that, I will hand it back over to JR, who will walk you through this in a demo.
Thanks, Elena. Let me share my screen again. So in the second part of the demo, what I will show you is the notebook experience. So what you will get to see when you launch a notebook session. I will hit some of the points around Condo Environments as well as ADS. I will briefly also touch on the model catalog and the deployment option that you have with focus on Oracle Functions. So at the end of part one of my demo, I created a notebook session. So it typically takes a few minutes before the notebook session is ready to open and use. So at the end, when the notebook is ready, you will see that the notebook is in an active state. So right now it's green and I can open my notebook session. So if you click on open here, you'll be directed to this standard, very familiar actually interface, Jupyter Lab that data scientists use. It's widely adopted among the data science community. So we didn't really do anything to the Jupyter Lab interface. It's the open source version. We just added a few extensions. Most notably the Environment Explorer and Notebook Examples. So I'm going to walk you first through the Environment Explorer one. So if you click on it, it's going to open a new tab in the launcher here. And so what you see here is a list of curated con environments that our service as that our team has developed. And so you can access and download those con environments inside of your notebook sessions. So those are called data science con environments. We have, I believe, 9 environments at the moment. There's 6 for CPUs and 3 for GPU-based machines. And they vary in their use case. So we have a con environment for general machine learning, for Onyx. We have others for data exploration, for doing development work in PySpark. You can leverage the NVIDIA Rapids framework for GPUs. We also have a database environment, as well as some of our older classic kernel environments that we also delivered. So you can install one or multiple of these environments inside of your notebook sessions, and you can browse them here in this Install Con Environments tab. So I've installed in my notebook session a couple of these. One is the NVIDIA Rapids environment, and the other one is a general machine learning for CPUs. This environment, general machine learning, also includes the ADS library, as well as AutoML and MLX for model explanations. And I can also take any of those condas. I can create my own. I can modify the content of those condas. I can add new libraries if I want to. And I can take that content and publish it. And once a conda is published, we'll show under the under the Publish Conda Environments tab, and it becomes available then to anyone else who can access the object storage bucket in which that conda environment is stored. So I've already actually installed a couple of these, and they're available in my launcher window here as separate kernels. So I have one for general machine learning and one for Rapids. Each one of those con environments, the data science con environments, come with its own set of what we call notebook examples. So notebooks examples are available through this extension here. So I'm going to click on this button so you can see. So we provide notebook examples. They're great tools to get you started with the different con environments. They give you instructions on how to access different features, different libraries that are available in those condas. So a very useful feature here that data scientists enjoy very much. I wanted to just go through one particular notebook example that's available in the machine learning, general machine learning one. It's called the employee attrition. So I like to go through this notebook because it showcases a simple use case with some of the key features of ADS are highlighted in that notebook. So I'm going to walk you through it. It's a simple use case. We have a data set, and our goal here is to predict employees who are going to leave the company. So it's an attrition use case. So the first thing we need to do is import all the libraries we're going to need. So we're going to use the ADS library. We're going to use as well a sklearn in this example. And then the first thing we want to do here is we're going to leverage EDS and the dataset factory object to pull the data and start the analysis. So the data actually in this case resides locally in my notebook session, but I could have connected to a database. I could have pulled the data from object storage, for example. So I'm going to pull the data, and I'm going to use the very useful show in notebook feature that's available in ADS. So once I pull the data set, I can visualize a lot of profiling information about my data set. So there's a summary information for every single feature in my data set. I get summary statistics. Here I get, I have different features like age, attrition, salary level, job function, commute length, and I have some summary statistics about every single one of those features that are generated by ADS. You can also look at the feature distributions and summary statistics here as well. So for each column in my data set, I get a distribution over values, which is quite useful. This is something that I would have to do as a data scientist. I would have to write perhaps hundreds of lines of code to generate the same output. But here with only a show in notebook call, I get the same output. I can also look at warnings. Warnings is kind of cool. So it gives me information. So what did ADS found to be interesting about the data set? What are the things I should be watching for? So it tells me that perhaps there's some columns with high cardinality. Some columns have large number of zeros or null values. Some columns have constant values in them. So these are the things that I should be watching for when I prep my data for machine learning model training. So another thing you can do with ADS is do some what we call EDA or exploratory data analysis. So the show notebook feature applies not only for the data set as a whole, but you can also use it for every single column in your data set. So here I show some summary statistics about my target column, which is called attrition. ADS also has the capability to apply automated data transformation to a data set. And so what I do here is I call the auto transform API of ADS. And ADS applies a series of transformation. So there's a logging output here that tells me what transformation will apply on what columns. And so there's an additional API called suggest recommendations, which will walk you through different steps that you can take to transform your data set based on what ADS recommends. But the auto transform is the other approach here. Oh, I wanted to just point out here that I've actually enabled logging. So I apologize, you will see large amounts of logging output. So I will walk through those pretty quickly, but you can actually disable that if you prefer through the ADS, through some of the ADS configuration parameters. So the next step is once you have a data set that has been prepared, cleaned, and featured engineered, you want to build and train a model, right? So there's a couple of options that you have inside of ADS. You have Oracle AutoML, which is, as Elena described, it's really an end-to-end AutoML engine here. So we do feature selection, hyperparameter tuning, adaptive sampling, and algorithm selection. You don't have to use AutoML. You can also use ADS Tuner, which is a hyperparameter optimization engine. So if you are using an open source library, for example, scikit-learn or XGBoost, and you already have an algorithm in mind that you want to optimize, and you can just pass it to ADS Tuner, and ADS Tuner will find the optimal set of hyperparameters for that particular algorithm. So it's quite useful. But you don't have to use AutoML. You don't have to use ADS Tuner. You can use your own library if you want to. You can use open source libraries directly. And then the machine learning, the general machine learning Condo environment, there's a whole bunch of those general of those open source libraries, including XGBoost and scikit-learn and LightGBM already available here. So what I did is I use AutoML actually to train my model. And so I'm going to skip through the log. AutoML is quite verbose actually. And I'm going to skip here to some of the API you can get access to once you train an AutoML model. So you can get access to the selected model parameters, the actual algorithm that was selected by AutoML. You can take a look at the selection trials for that algorithm. You can look at the different feature selection trials that AutoML went through. Same thing would happen for hyperparameter. So there's a very rich visual API. But as I said, you don't have to use AutoML. And so in this particular cell, what I do here is I decided to train a custom sort of random forest classifier based on the scikit-learn framework. And so what I'm doing here is I'm training that random forest classifier and I'm converting it to an ADS model object. This is from the from estimator method. And what this allows me to do is what it does is that it unlocks a bunch of additional capabilities. So once an open source model is turning into an ADS model, then I can leverage the ADS evaluator object as well as the ADS explainer. So what Elena mentioned in our presentation is that with a simple line of code, you can get a very comprehensive evaluation profile of your model. So in this case, we're talking about attrition. So it's a binary classification problem, 0 and 1, true or false. So I generate automatically PR curve, ROC curve, lift chart, gain chart, and a bunch of confusion matrices from the different models that I've trained. So I've trained an AutoML classifier. I've trained also a random forest classifier. And I have a sort of a dummy model also, just a simple kind of a random prediction 50-50. So, or sorry, based on the class proportion here. So just for comparison purposes, I have this dummy classifier. So I can use the evaluator API to also compare the metrics, both on the training and the testing data set. So I can immediately see which of my models is doing better across those different diagnostics. But as Elena mentioned, you may want to go a little bit deeper here. Simple evaluation metric or simple ROC curve are going to tell the whole story. You want to also understand how the model behaves, both at the global level and also for each individual prediction that the model is making. So you can do this through the ADS Explainer API that is part of ADS. So we provide a series of diagnostics, and I actually illustrated a few of them in this notebook, one of which is this global feature importance. So as I said before, this is the EDA explainer is at the global and at the local level. So what I'm showing you here is the global model agnostic feature importance score for this particular algorithm and data set. So you can understand here that some of the features are more important than others. In this case, monthly income seems to be the dominant feature here at the global level. We also provide additional diagnostics, partial dependency plots. We also provide ICEs. So here is just a simple PDP plot for overtime, the overtime feature. We have independent conditional expectation plots as well, in this case for the overtime feature. Let me just show you some of the PDP charts that I've generated for this particular use case, one for job versus overtime. And then I have another one here. I believe this is the same one, but for the different value of the target variable. So global is great. You may want to go at the local level and really try to understand for a particular prediction, what is contributing to that prediction. So I'm doing this here using the what's called a local explainer. It's an improved version over the open source Lime library. So and we've done quite a few things to this to make it run faster, to provide more accurate local surrogate models in the vicinity of the data point that you want to explain. So I'm showing this here where I take a particular row in my data set. So this is a particular employee, and then I'm looking at the predictions that my model is making for that particular employee. And so we give you access through a very extensive dashboard that compares the model, the global model prediction, and the surrogate local model, and as well as the explanation that are coming from that surrogate model. So we can see here that perhaps in this case, over time, and the feature called number of companies that the employee has worked before, are contributing to the predictions very significantly, but in different directions. So that's an interesting thing. So you can look at local explanation as well as global explanation with ADS Explainer. So at the end of this journey, you may want to save a model to the model catalog. So ADS provides a simple to use API to prepare the model artifact as well as to save it to the model catalog. So I don't have an example in this particular notebook, but there's other notebook examples, most notably the model catalog example that walks you through the process of creating a model artifact as well as saving it to the model catalog. But let me go back here to the console because I want to show you here one example of that notebook, of that model here in the model catalog. So as I said before, a couple of actions you can take: create a notebook session, create and save a models. You can create and save a models from a notebook session using ADS. You can also do it from the console directly by clicking here on the create model action. I already have saved a model here. I call it test model 1. So if you click on it, you see some amount of information about my model. There's the provenance information. So if I were to work in a Git repository, for example, that's going to keep track of my Git repo, the commit, the branch, the model directory, and the script that I use to train my model. Once I'm satisfied, I can download the model artifact. I can use the OCI Cloud Shell service to download the model artifact using the CLI. I believe I have an example of this here. So you can use a Cloud Shell terminal to download the model artifact, and then you can take that model artifact, build a function image, and deploy that model as an Oracle function. So in this particular application here that I've called machine learning models, let me just minimize my Cloud Shell window. I have deployed previously a number of Oracle functions. So these target different models. One is around attrition, employee prediction. I have one on speech command detection, and one that classify X-ray images using a deep learning model. So you can take your artifact, deploy it as a function. Once the model is available as an Oracle function, then it can be consumed by external application. The model is essentially at this point a REST API endpoint that you can then incorporate into your application. So this is sort of giving you an end-to-end story for your models, from a notebook session to the model catalog through deployment with Oracle functions. So I'm going to turn the mic back to you, Elena.
Thanks, JR. Share my screen. So wrapping up with some key takeaways. First of all, the OCI Data Science service is easy for a data scientist to get started, get to work. You don't need to do any sort of DevOps heavy lifting, provisioning, maintenance of infrastructure. Again, the service team does all of that for you in a fully managed way. It is built for teams to collaborate together on data science problems. From the projects feature to the model catalog, we think about how teams of data scientists can audit and reproduce each other's work. It's focused on the complete model lifecycle management, as you've seen in this presentation, how to get from data access all the way through deployment and beyond. You can access data from nearly any source with nearly any data format. It includes your favorite open source tools and machine learning frameworks, as well as supplementing it with market-leading Oracle technologies like model explanation and AutoML. Next, OCI Data Science service is a native service of OCI, meaning that we benefit from all of the great features of Oracle's Gen 2 cloud, including faster networking performance. And lastly, again, as part of the OCI family, we are designed for enterprise scale and security. And with that, we will be taking a few questions. First question comes in for JR. How can I use GPUs to accelerate my model development?
So you can use GPUs these days. You can use GPUs actually for a variety of use cases. It used to be that GPUs were used to train deep learning models, but recently there's been really I would call it a democratization of the kind of tasks that you can run on GPUs. And this is coming from, especially from the NVIDIA Rapids framework. So you can use GPUs to nowadays to ingest data, do data transformation, feature engineering, and then do model training, not just deep learning model, but also just, training your simple random forest model, for example, on GPUs, and you can get significant speed up. So in the OCI Data Science service, we give you the option to use notebook sessions on GPUs, with the Pascal generation of GPUs with NVIDIA, or with a V100 GPU as well. That's possible. You can launch a notebook session you can launch a notebook session on GPUs with 1, 2, or even 4 cards for larger workloads.
Okay, next question is, can I use this service in a multi-cloud or on-premises environment? So as I mentioned, you can access your data from any source. So you could have a data management platform on premises, a database there, or you could have your data in another cloud and bring that in to the OCI Data Science service. The OCI Data Science service itself only runs on OCI. In addition to all of that, we also have a OCI product called Dedicated Cloud at Customer. So if you have, basically what a dedicated region is that OCI basically manages your data center for you. If you're interested in this, look it up on our website, Dedicated Cloud at Customer. Okay, next question, I'll throw this to JR. How much does it cost? And how does it compare with AWS, Azure, and Google Cloud?
So our business model is actually quite simple. So we charge for the infrastructure that you use. We don't add any tax or overhead on top of that. So for example, if you're launching and running a notebook session, we're going to charge you for the VM itself. And this is charged typically by the number of OCPU hours that you use. And then in addition to that, we'll also bill you for the block storage that you are consuming. So this is a pretty simple, straightforward business model. And it compares favorably with AWS, Azure, and Google Cloud. So we're actually significantly cheaper because we're only charging for infrastructure and we're not adding any tax overhead on top of that.
Great, so at this point, we have no further time for Q&A. So thank you for joining us. Please visit the event agenda for links to sessions at the address on your screen.